Hello. Hello.
Now am I audible? Subhajit? Ruchida? Please tell me. Okay. Now am I audible? Okay, thank you, thank you, thank you. Uh, yes, yes. So here we see that if you consider z curl is y curl minus a theta naught. In that case, we see that our parameter theta curl reduces to delta curl, where delta curl consisted of delta 1, delta 2, delta s number of parameters, and in that case dispersion of z equal to sigma square in. So here if you take delta 1, delta 2, delta s, in that case we need no restriction. Okay, so please tell me, have you any problem regarding method 1? Can I repeat this method 1 again? Method 1, actually this is the restrictions, okay? H prime theta curl xi curl, and your problem is to estimate lambda curl prime theta curl under this restriction. Actually, if you have a no restriction, you know lambda curl prime theta curl is estimable if and only lambda curl prime belonging to the row space of A. But if you have this restriction H prime theta curl equal to xi curl, in that case, and if you know this is a consistent equation, so you can write this thing is a theta curl is a, if theta curl is a general solution, then you write theta curl as theta naught plus b delta curl, where theta curl is a particular solution, that means H prime theta naught equal to xi curl, and b is a, or b belonging to the columns of b belonging to the orthocomplement space of the row space of H prime. That means this is the solution of homogeneous equation H prime theta curl equal to 0. Beta delta curl is a solution of homogeneous equation H prime theta curl equal to 0. And now you see that since expectation y curl equal to a theta curl, and if you put this portion, this theta naught curl plus beta delta curl, you see that a theta naught plus a b delta curl, and if you take z curl equal to y curl minus a theta naught, then you see that this is the usual model z curl u delta curl sigma square in, where delta is consisting of s parameters, where no with no restrictions. Okay, and in that case this is lambda curl prime theta curl is written as this, and you see that this is estimable because lambda curl prime theta curl if you replace this theta curl hat by theta naught curl hat plus beta delta curl hat, then you see that this is nothing but a lambda curl prime theta naught curl hat, because you know this portion that theta curl hat naught, this is a, because this is a particular solution, and delta curl hat, you obtain delta curl hat from this equation u curl prime u curl delta curl equal to u curl prime z curl. Okay, so therefore lambda curl prime theta curl is estimable. So please tell me, have you any question, any queries, Shubhrojit? Problem is to estimate lambda curl prime theta curl. Okay, and this is not a usual model because h prime theta curl equal to xi curl. So okay, so we need to reduce this model to unrestricted model, that is usual model, using this transformation z curl equal to y curl prime a theta naught curl, and we see that under this transformation this is a usual model, where in this model we have only s parameters with no restrictions, and we see that now lambda curl prime theta curl is estimable because theta naught curl hat is known and delta curl hat also known, because delta curl hat is a solution of this equation u prime u delta curl equal to u prime z curl. Okay, so this is method 1. Now method 2. Here the blue of an estimable parametric function is given by lambda curl prime theta curl, where theta curl hat minimizes y curl minus a theta curl prime y curl minus a theta curl under the restriction h prime theta curl psi curl. Now using Lagrange's multiplier, undetermined multiplier, we minimize x square equal to I from 1 to n yi minus ai1 theta 1 aip theta p whole square plus lambda 1 h1 prime. Actually this portion lambda curl prime h theta curl minus I curl. Okay, so yi minus ai1 theta 1 aip theta p, or otherwise you can write this thing as h prime theta curl equal to xi curl, and you h prime theta curl equal to xi curl, and you take the columns of h as h1 h2 hk. Okay, so then h1 prime theta curl plus h2 prime theta curl plus sorry h1 curl prime theta curl, h2 curl prime theta curl, hp prime theta curl. So this is equal to xi1 xi2 xi, I think xi k, sorry, this is xi k, okay. So this equal to hi curl prime theta curl xi I from 1 to k. So instead of this we can write this as lambda I from 1 to k hi curl prime theta curl xi I. Okay, now minimize this part with respect to theta 1 theta 2 theta p and lambda 1 lambda 2 lambda k, and the normal equations are, if you differentiate this with respect to theta curl equal to 0, then you get a prime a theta curl plus h lambda curl a prime a h prime, I think. Please check this thing. And del s square del lambda curl equal to 0 curl, this means this portion gives h prime theta curl xi curl. Okay, please check this. And where lambda curl is lambda 1 lambda 2 lambda k. So you can get base linear unbiased estimator of lambda curl prime theta curl using this way, and lambda base linear unbiased estimator of lambda curl prime theta curl is lambda curl prime theta curl hat, where theta curl is a solution of these two equations. So this is the method 2. So either you reduce number of parameters or you can use Lagrange's multiplier. So in both cases we get base linear inverse system of lambda curl prime theta curl. Okay. So please tell me, have you any problem regarding method 1 and method 2? Any doubt? Shubhajit, Shubhadeep, Shohini, Ruchira, please tell me. Are you hear me, Shubhajit, Shubhadeep, Shohini? Oh, Shubhajit always no doubt. And Shohini? Shubhadeep? Okay, thank you. Linear function, sum of square due to linear function. Consider okay, consider a set of k linear function C1 y curl, C2 prime y curl, Ck curl prime y curl, where Ci curl equal to Ci1, Ci2, Cin, I from 1 to k, linear function are said to be independent if the coefficient vector C1 curl, C2 curl, Ck curl are independent. See, a set of, consider a set of linear function C1 curl y curl, C2 curl y curl, C curl y curl. Linear function means a linear function of a observations. So these linear functions are, k linear functions are independent provided C1 curl, C2 curl, Ck curl are independent, where Ci's are coefficient of linear function, coefficient vector. These are the coefficient vector. Okay, this is the definition. The linear function, are said to be orthogonal if the coefficient vector are orthogonal. That is, Ci curl prime Cj curl equal to 0 for all I not equal to j. For all I not equal to j. Okay. Strip tail, I denote this strip tail by linear set of functions actually set of linear functions. Set of linear function generated y. C1 curl y curl, C2 curl y curl, ck curl y curl. So this is a set of all function which can be obtained by linear combination of C1 curl prime y curl, C2 curl prime y curl, ck curl prime y curl. Okay. That means any function, any linear function script belonging to script tail is sometimes called linear set. Actually, this is called linear set. The linear set script tail. So any linear function script tail has the form function belonging to script tail if or any linear function belonging to script L has the form lambda 1 C1 curl prime y curl, lambda 2 C2 curl prime y curl plus lambda k ck curl prime y curl. So this is equal to this. Next definition. S is due to sum of square due to script tail is defined by the square length of the projection of y curl on the vector space generated by C1 curl, C2 curl, ck curl. That is, SS due to script tail equal to y naught norm of y naught square, where y naught is a projection of y curl on script tail C1, C2, ck, that is the vector space. I think it is better to denote script capital V. Vector space generated by C1, C2, ck. And this is what norm of y naught square is nothing but a y naught curl prime y naught. And since this is a projection of y curl on C1, C2, ck, so it should be written as a linear combination of vector C1, C2, ck. So I write y naught curl equal to T1 C1 curl plus T2 ck curl, C2 curl, Tk, ck curl. Okay. So now y naught curl minus sum over ti ci curl I from 1 to k, this is orthogonal to Cj curl j from 1 to k, that is Cj curl. You know this thing because y naught is this, that means y naught minus this vector belonging to ortho complement space of V. Okay, so this is Cj prime y naught curl minus sum over I from 1 to k ti ci curl equal to 0. So this means Cj curl prime y curl c t curl equal to 0 curl. So this implies, and this is for all j from 1 to k, hence c prime y curl c t curl equal to null matrix, then c prime c t curl equal to c prime y curl, and this is always solvable equation. 40, and let, since it is solvable, so assume that t hat curl equal to t naught t1 hat t2 hat tk hat be a solution of c prime c t curl equal to c prime y curl, and y naught is a projection of y curl on sorry, please, this should be y, not y naught. Okay, this is my mistake. Please rectify this thing. This is y. Okay, actually y can be written as a y naught plus y curl minus sum over I from 1 to k ti ci curl. Okay, so this belonging to the ortho complement space of the V C1 C2 Ck, and this is belonging to V. Okay, so for this reason this portion is orthogonal to Cj. Okay, and see that y naught is this. This is y naught curl. So please change, this is y curl, not y naught. Okay, so y naught is a projection of y curl on V C2 curl Ck curl, which is equal to C curl prime T curl hat, where T curl is obtained from, T curl hat is obtained from this equation. Okay, so therefore SS due to scriptal, this is sum of square due to scriptal is y naught curl prime y naught curl equal to c curl prime t curl hat whole prime c curl prime t curl hat. Okay, so therefore t curl prime hat c prime cc prime t curl hat, and simply we write this as t curl prime hat c prime y curl, and degrees of freedom is equal to dimension of this V and this is equal to R, that is rank of matrix C. This C matrix consisting of whose columns are C1, C2, Ck. So now remark C1 curl prime y curl, C2 curl prime y curl, Ck curl prime y curl are all independent, then SS due to scriptal is nothing but a y curl prime C, C prime C inverse C prime y curl. So you can prove this thing easily, since according to the, we know the scriptal, this is a linear set generated by k linear function, then T1 equal to C1 curl prime y curl, T2 equal to C2 curl prime y curl, Tk equal to Ck curl prime y curl, and SS due to scriptal, this is equal to y naught curl whole square, this is y naught curl prime y curl equal to t curl prime hat c prime y curl, and t curl prime, since these are all independent, means C is a full rank matrix, that is a non-singular matrix. So C is invertible, C prime is invertible. I think it is better to say full rank matrix. That means C prime C inverse exists So this means t curl hat equal to c prime c whole inverse c prime y curl, and therefore SSL equal to y curl prime c c prime c inverse c prime y curl. Okay, next remark. Please tell me, have you any queries regarding this remark before going to the next remark? Shubhajit, please tell me. Shubhadeep. Now next remark. C1 curl prime y curl, CK curl prime y curl are mutually orthogonal. Okay, thank you. Then SS script L equal to I from 1 to a Ci curl prime y curl whole square Ci curl prime Ci curl. So see that mutually orthogonal means CIs are then matrix C prime C should be I. This means C prime C should be I. So C prime C inverse again I. So this means y curl prime C prime y curl. So that is equal to, actually not I. You need to normalize these things. If you assume this is a mutually orthonormal, then this is I. Otherwise, it is the form of this should be. I erase this portion fast. See that C prime C prime C. This is equal to C1 curl C1 0 0 0 C2 curl C2, because this is just a orthonormal. If it is unique length, then this should be 1. Otherwise, this is just C1 curl C1, C2 curl C2. Okay, so this is a diagonal matrix whose diagonal elements are C1 C2, C2 prime C2, and C is a CK. Last diagonal element is CK prime CK. So therefore this should be not this. This is y curl prime C diagonal C1 curl C1 curl C1 curl prime C1 C2 curl prime C2 curl CK curl prime CK C prime y curl. So we simply get this from I from 1 to k ci curl prime y curl whole square ci curl prime ci. Okay, so please tell me, have you faced any problem? And automatically, if another remark, this is due to c1 curl prime y curl ck curl prime y curl, which are mutually orthogonal, then SS due to script tail is nothing but a I from 1 to n ci curl prime y curl whole square, because in that case ci curl prime ci equal to 1. Okay, so please tell me, have you any problem? So another remark, SS due to y1 y2 yn, which we call sum of square due to SS due to, we write this as epsilon y epsilon e curl prime y curl, e1 curl prime y curl, e2 curl prime y curl, en curl prime y curl, where ei is a canonical basis, or we know ei curl equal to 0 0 0 1 0 0. This is the ith position prime. So if you use this result, you just get sum over 1 to n yi square. So SS due to y1 y2 yn is nothing but a summation yi square. Just put ei curl equal to ci curl equal to, replace ci curl prime by ei curl prime, then this is, so this is nothing but a yi square and I from 1 to n sum over I from 1 to n. Okay. Shubhodip, in third remark, the linear functions are orthogonal or orthonormal. Third remark means this is, oh sorry, thank you Shubhodip, this is mutually orthonormal, that is orthogonal with unit length, orthonormal. Okay, thank you. So and this is due to simple linear function, this is due to simple linear function is equal to c prime curl y curl whole square c curl prime c curl with degrees of freedom 1. So please tell me, have you any problem? So today I want to end the stream. Next day I will discuss, I will continue the sum of square due to linear functions and consider some problems, and then I will consider linear hypothesis. Okay, so please tell me, have you any problem? So we will meet again 10 p.m. Sunday, 10 a.m. Sunday morning. Okay, so can I in the string. Have you any doubt? Please tell me. So please tell me, have you any doubt and queries? Shubhajit, Shubhrojit, Shubhadeep, Shohini, Ruchira, please tell me. Thank you, Shubhrojit. Thank you. Okay. Oh, thank you, Ruchira.